this question, we're asked to copy and complete the table for y equals to x squared minus 2x minus 3. Let's just get started. So for x equals to minus 3, when x is minus 3, y will be what? Minus 3 squared minus 2 into minus 3 minus 3, which is 9 plus 6 minus 3, and that's 12, right? So that means the answer here is going to be 12. When x is negative 1, we will have y equals to negative 1 squared minus 2 multiplied by negative 1 minus 3, which is 1 plus 2 minus 3, and that's 0. When x is 0, y will be 0 squared minus 2 multiplied by 0 minus 3, which is simply 0 minus 0 minus 3, which is negative 3. Negative 3. When x is 2, that means y is going to be 2 squared minus 2 multiplied by 2 minus 3, which is 4 minus 4 minus 3. That means the answer is also minus 3. And at the same time, when x is 3, y is going to be 3 squared minus 2 multiplied by 3 minus 3, which is 9 minus 6 minus 3, and that will give us 0, right? 0. Lastly, when x is 4, y is going to be 4 squared minus 2 multiplied by 4 minus 3. 4 squared is 16 minus 8 minus 3, which is 5, right? So we just finished calculating for the values of y in the question. So you can solve the way I've solved by solving it one by one, or you can decide to solve it in a tabular form. Before we draw the quadratic graph in question 1b, let us solve question 1c. That is, we are also asked to draw a linear graph of y equals to 2 minus 2x. So before we can draw the graph, we need to know the values of y for the equation 2 minus 2x. So it is actually important that you do this before you draw your graph, because that will aid you to know how to calibrate your graph. Now, x is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. So using the tabular form, you are going to pick each of the elements in the equation. In this case, we have a constant variable first, which is 2. So we are going to write the 2 all through. Then we have minus 2x. So now solve for minus 2x individually. Minus 2x in the first case will mean minus 2 times minus 3, which is 6, right? For the second case, it will be 4. For the third number, which is x equals to minus 1, the value of minus 2x will be minus 2 times minus 1, which is 2. Minus 2x times 0 is 0. Minus 2x times 1 is minus 2. Minus 2x times 2 is minus 4. Minus 2x times 3 is 6. Minus 2x times 4 is negative 8. Oh, sorry. Minus 2 times 3 is negative 6. Minus 2 times 3, negative 6. Then minus 2 times 5, negative 10. But we are yet to solve for y, because y is 2 minus 2x, right? So now we are going to add 2 plus 6, 8, 2 plus 4, 6, 2 plus 2, 4, 2 plus 0, 2, 2 plus negative 2, 0, 2 plus negative 4, negative 2, 2 plus negative 6, negative 4. This will give us negative 6, and this will give us negative 8. Please take note that we are not going to subtract again. For this column, we are not going to subtract to get the values in in this row, we are not going to subtract 6 from 2. No, because we already evaluated minus 2x. I didn't mean what we did in the first place is just 2x. So for example, it is just 2x that we wrote here. Then we will have to subtract. So please make no mistake of subtracting even after you've evaluated for minus 2x. So those are the values of y for the linear graph. So for the quadratic graph, we'll see that the minimum value of y is -4, right? Which is this right here. And the maximum value is 12, right? But for the linear equation, the minimum value of y is -8 and the maximum value is 8, right? So that means what you are going to note on your graph is going to be from -8 to 12. If you consider just this quadratic equation, you just realize that after drawing your graph, you need to clean it again when you want to draw the linear graph. So you need to consider this first before even doing anything on your graph sheet. Now that we know that for y, this is where we are inputting values from -8 to 12. Now for x, it is simply from -3 to 5, right? So the scale we are asked to use is for x axis, we are asked to use 2 centimeters to 1 unit. So what does 2 centimeter actually mean on a graph? Well, one big box has a dimension of 2 centimeters each. So from here to here is 2 centimeters. From here to here is also 2 centimeters. Here to here also 2 centimeters, and as well for this. So that's what 2 centimeter looks like. That means one big box is what? 2 centimeters on each side. So -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, even though we don't need it. Then for y, we are sketching from -8 to 12. So if this is 12, 10, 8, 6, 4, 2, 0, -2, -4, -6, -8. You can see that even though we did not write 0, 1, 2, 3, 4, 5, 6 for with the y-axis, we are still using the scale required of us. We are asked to use 1 centimeter to 1 unit on y-axis. That means from here to here is one unit. 8 to 7. From 7 to 6 is also 1 unit. I hope you understand what I meant. Now that we've done this, so let's insert our values. For the quadratic graph, when x is -3, y is 12. So this is x at -3 and this is 12, right? So this is the point of intersection. When x is -2, y is 5. Well, this is x at -2 and this is 5 right here. This is 5 for y. This right here, this place is where 5 is. So this is going to be the point of intersection, right? Then when x is -1, y is 0. When x is -1, y is 0. When x is 0, y is -3. So this is x at 0 right here, but y is -3. So this is where -3 is. Then when x is 2, this is x at 2, and then y is when x is 1, okay, I've jumped. When x is 0, y is -3. When x is 1, y is -4. This is where -4 is for y. So this is when x is 1, and this is where y is -4. So that's the point of intersection. When x is 2, y is -3. This is x at 2. Then y is -3. This is -3. Also, when x is 3, y is 0. When x is 3, this is x at 3, then y is 0. When x is 4, y is 5. This is x at 4. So we are going to trace it to where y is 5. Well, this is where y is 5, the point of intersection. Then lastly, when x is 5, y is 12. Okay, so if we trace it, this is 12. So this is the point. That means we've noted all the points for the quadratic graph. So using a French curve or the traditional broom that we use, we can connect the points. Now that I've joined the points, it's time to draw the graph of the linear equation. So when you draw graphs, please always label it. So this first one is for y equals to x squared minus 2x minus 3, right? So for the linear graph, when x is negative 3, y equals to 8. So this is the point. Okay, let me use another ink this time around. Let me use a black ink. So when x is negative 3, y is 8, right? So this is the point where x is minus 3 and y is 8. When x is negative 2, y is also... Okay, I've made a mistake here actually. The mistake was from when I was copying the table. This is not supposed to be minus 2. This is supposed to be 6. So, pardon me, it was from when we solved it, it was actually correct. It was when I was copying it to this page that I made the mistake. Now, when x is negative 2, y is 6. So, this is the point where x is negative 2 and y is 6. When x is negative 1, y is 4. This is the point where x is negative 4 and negative 1 and y is 4. When x is 0, y is 2. Okay, this is 2 right here. When x is 1, y is 0. Okay, this is it right here. When x is 2, y is negative 2. This is negative 2 for y and 2 for x. When x is 3, y is negative 4. This is the point of intersection of that. When x is 4, y is negative 6. Negative 6. And lastly, when x is 5, y is negative 8, which is this. Now, you can see that this is even a linear graph. So I'm going to join the points. I have joined the points, and this is the graph of y equals to 2 minus 2x. So to answer question B, 13b, we're asked to determine the root of x squared minus 2x minus 3. Well, that's simply the point of intersection of the two. That's the point where the quadratic curve cuts the x-axis. So the first point where the quadratic curve cuts the x-axis is at what? And that's where this is the point right here, where x is minus 1 and x is 3. So that means for 13b, the root, using the graph, the root of the equation is x is minus 1 and x is negative 3. For the 13c, we've actually done that. We've drawn the graph of y equals to 2 minus 2x. And for D, we are asked to deduce the root of the equation x squared minus 2x minus 3 equals to 2 minus 2x. That is, they are equating the quadratic graph to the linear graph. So simply the solution is going to be the points of intersection of the two graphs. So if you look closely, it is going to be this point right here, as well as this point right here. So if we trace it, well, let me trace that. So at this point right here, as well as at this point, those are the 2 points where the quadratic graph and the linear graph intersect. Remember that this is exactly where they intersect, right? And okay, don't let me use the blue ink so that you can see clearly. This point, this here and this here, those are the 2 points of intersection of the linear graph and the quadratic graph. So when you trace it to the x-axis, whatever answer you get, that's what is going to be the solution to the equation. So let's now that we've traced this, let's actually find out the exact values from this graph. So if this is minus 2, this point here, if it is minus 2 and this is minus 3, that means the middle right here is minus 2.5, right? So between here and here, we have minus 2.5, right? So let's say if the small boxes are very blurred, so that's why you may not see it so clearly. However, if the distance between, if here right here is minus 2 and here is minus 2.5, that means the middle here is going to be what? Negative 2.25, and that's the point of intersection for the negative value of x. So this is the first solution. For the second one, if this is 2 and this is sorry, that's not 2. Okay, yes, that's where x is 2. That's the point at which x is 2, and this is the point at which x is 3, right? So if this is 2, that means this middle line right here is 2.5, right? So this is 2 and this is 2.5 and this is 3, right? So what will be the line between 2 and 2.5? It is also 2.25, right? So that means here we have 2.25. So those are the points. That's the solution to the question. The root of the equation x squared minus 2x minus 3 equals to 2 minus 2x, which we found, and I mentioned that it is the point of intersection of the quadratic and linear graph. The roots are negative 2.25 and positive 2.5. Sorry, 2.25 and 2.25, or we can say negative 2.3 and 2.3 if we decide to approximate it. So that's the root of the equation. Now, I'll actually prefer not to approximate it. So in Waec marking guide, there's always a margin of error. What do I mean? The exact value that I got here might not be your own exact value when you try it on a paper and pencil, but definitely it is going to be close. Probably you will get negative 2.2 and 2.2, or you will get 2.3 and 2.1, or something within that margin, something very close to this. So if you get something not close to this, that means you've made a mistake, and you should trace where that mistake came from. Now, for the last part in this question 13, we are asked to find the minimum value of y. Well, from the graph, the minimum value of y is actually very obvious, because this is the point at which y, sorry, I just erased that. This is the point where y is minimum, and that's minus 4. Therefore, the minimum value of y is negative 4.